Hello everybody. In this video we'll be covering one of the sections from chapter 8 of our text entitled Quantities and Chemical Reactions. In this video we're going to discuss calculating the yield of a chemical reaction. I want to go back to our pancake making analogy one more time. Let's now assume that we are making pancakes and we spill some of the batter, or we burn some pancakes, or we drop one on the floor, or something else happens, and we only wind up making 11 pancakes. The actual amount of product made, our 11 pancakes in a chemical reaction, is called the actual yield. Alright, so our 11 pancakes would be our actual yield in this scenario, and if we're doing a chemical reaction, we're also not going to get our actual theoretical yield, but some value that's a little less we're going to call our actual yield. We can determine the efficiency of making pancakes by calculating the percentage of the maximum number of pancakes we actually make. In chemical reactions, we call this the percent yield. So our formula for percent yield is going to be the actual yield that we got after we did the reaction divided by the theoretical yield, the maximum amount we could have made based on the limiting reagent. We're going to multiply that by 100% and we get our percent yield. In our pancakes analogy, that means that we made 11 pancakes, but we had a maximum theoretical amount that we could have made of 15 pancakes. Therefore, we got a 73% yield of pancakes, and we're 73% efficient at making pancakes. So as we did with the pancakes, in order to determine the theoretical yield, we should use reaction stoichiometry to determine the amount of product each of our reactants could make. The theoretical yield will always be the least possible amount of product. Okay, so we figured out from our limiting reagents how to calculate theoretical yields. Because of both controllable and uncontrollable factors, the actual yield of the product is always going to be less than our theoretical yield. Okay, we're not going to be able to create mass and get a higher yield than our theoretical yield. Our actual yield is going to be a little bit less. Okay, just like how we had enough flour to make 15 pancakes, we're not really going to somehow be able to make 16 pancakes, but we might mess one up and make fewer than 15 pancakes. So we have our usual issue here, which is in the lab. The balances don't measure moles directly. They measure the amount in grams. This is going to mean that we must add 2 steps to each of our calculations. First, to convert the amount of each reactant to moles, and then convert the amount of product into grams. So let's take a look at an example problem here. When 11.5 grams of carbon are allowed to react with 114.5 grams of copper oxide, in the reaction below, 87.4 grams of copper are obtained. So we have this reaction here. It's going to be copper 1 oxide. So what are we given? We're given the mass of carbon, one of our reactants. We're given the mass of copper oxide, one of our reactants. And we're being given the mass of one of our products, the copper solid. We're being asked to find the limiting reactant, the theoretical yield, and the percent yield. Our solution map is going to start off looking a lot like the one for the limiting reagent problems that we've already done, because that's exactly what it's going to be. We're going to go from these masses we're given to the moles of those reagents, to the moles of product that we could possibly have made, and then figure out what the mass of those products are that we could possibly make. Now, before we could stop here and determine which one was the limiting reagent, but we wouldn't have known the masses. That's just something to keep in mind. You can determine just the limiting reagent based on the moles. But if you want to calculate a percent yield or a theoretical yield, you need to do this extra step to go to the masses. We need to gather our conversion factors for each one of our steps. And again, these are going to be based on atomic masses and formula masses that we would calculate from the periodic table, and then stoichiometric ratios that we're getting from our equation up here. Finally, we're going to need to choose the smallest to figure out which one is the limiting reactant. And we'll need to apply our percent yield calculation. So first, we start with our mass of carbon, and we calculate that we could have produced 122 grams of copper. Next, we start with our copper oxide. And after we apply our conversion factors, we see that we could make 101.7 grams of copper. Therefore, because this guy is smaller than this guy, this is going to be our theoretical yield, and the copper oxide is going to be our limiting reactant. Now, we know from the problem up here that we actually produced 87.4 grams of copper. We know from our theoretical yield that we could have produced 101.7 grams of copper. We pump those into our percent yield equation here, and we see that we have 85.9% yield. And for our check, we should be getting a percent yield that is less than 100%, because our actual yield is always going to be less than our theoretical yield. Let's try one more. How many grams of N2 gas can be made from 9.05 grams of ammonia reacting with 45.2 grams of copper oxide? We're given an equation for it here, and we're asked another question. If 4.61 grams of nitrogen are made, what is the percent yield? So we are being given these masses, and we're being asked to find the mass of nitrogen that is going to be produced in our reaction. Our solution map is going to be the same as the others. We need to go through the moles in order to figure out the mass of nitrogen that's produced from either of these two reactants that we have. We'll need the formula masses for all of these guys in order to convert between mass and moles and mass. And then to convert from moles to moles, we'll need the stoichiometric ratios that are coming from this equation up here. For instance, there's 1 nitrogen for every 2 ammonia gases. We'll have to choose the smallest one here. That will be our theoretical yield. And then we'll have to apply our percent yield equation. When we start with ammonia gas and apply our conversion factors, we see that we get 7.42 grams of nitrogen gas. And when we apply it to our copper oxide, we see we get 5.30 grams of nitrogen gas. Now we need to make our decision. Which of these is our theoretical yield and our limiting reagent? We go with the smallest one. Therefore, that's going to become our theoretical yield. And copper oxide is going to be our limiting reagent. So now we know what our theoretical yield was to put into our equation, and we know what our actual yield was from the problem. We put that into the calculation, and we see that we got 87% yield. And again, for a check, our percentage should be less than 100%.